chaps. Today we're going to learn about power. So we have two lessons, quite big lessons, about how to calculate gravitational potential energy and also weights, okay? And then the last lesson was about how to calculate kinetic energy. Now these are concepts that we already dealt with last year. We know what kinetic energy, gravitational potential energy, and weight are. We just learned how to calculate them. But today, power is something new that we haven't really come across it. Now, what is power? What is power? Okay? And it'll be interesting. I like to hear, just take a minute and think, what is actually power? What does it mean, power? What does it mean to be powerful? Okay? Right? It actually means something very specific in physics. And it means not the amount of energy you have, it's the amount of energy a machine can use per unit time. Okay? So machines add energy. Okay? Machines add energy to objects. Okay? They can add a lot of energy, they can add a little bit of energy. For example, a motor in a car, okay, increases the kinetic energy of the car. And it adds energy. Okay? Now, power means how fast can you add that energy. So a powerful engine is one that can increase the amount of energy, the kinetic energy of the car, in a very short time. It's a rate of transfer of energy. Rate of energy, I don't want to say the word creation, because we're not creating energy, we're just transferring it from chemical to kinetic in the case of a motor, but it's the rate of increase of energy. Okay? So power is defined as the amount of energy that we add to a system divided by time. Okay? And from here, the units come around. Okay? So energy, the units that you come across are joules. Time can have many units, second, minutes, hours, but we use usually seconds. Okay? Now, if you use that combination, joules per second, we have a specific name for that unit, which is the unit of power, and that is watts. Okay? W, which stands for, I'll write it down here, watt. Okay? So if you were in class, I would say, what is the unit of power? And you would say, like, I don't know, what is the unit of power? What is the unit of power? It's a joke, because what is not like what is actually the unit of power. Okay, so here's my joke, I just had to put it out there. Okay, what is actually the unit of power? Okay, watts. Okay, right. Okay, in terms of symbols, we're going to write like this. P stands for power, obviously. E stands for energy, and T stands for time. Now, sometime, okay, it might slip up in a test or two. Instead of instead of E, you might have the letter W. Okay, and I'm going to try not to do that, but the more accurate definition of power is what I said, okay, which I'll write it down now. But instead of energy, we use the word work. It's the rate of transfer or rate of work created. Okay, work is to do with energy. It's not exactly the same, or it is a type of energy. But I've decided not to get into this right now. I'll leave that to Mr. Martin and Dr. Lobi to do that with you in grade 11. Okay? But just to let you know that sometimes instead of E over T, you might have W over T. Okay? Let's just quickly write down the definition. Okay? The definition of power. Okay? I will just say rate of transfer of energy system. Okay? That's it, guys. Please copy that and then we'll solve a couple of problems. Okay, chaps, so let's start with some questions. 200 joules are added to a system. I don't know, I didn't make it pretty, just as it is, okay? 200 joules are added in 5 seconds. Calculate the power of this machine, okay? Machine add 200 joules every 5 seconds, okay? What's the power, okay? We look at here, right? P equal energy over time. Energy is 200 joules. Time is 5 seconds. 200 over 5 is 40. And because I work with joules and second, the answer will be in watts. 40 watts. Okay, I'm sure you heard a wattage, okay, watts of light. Okay, how many watts does the light have? Well, that's how much energy, in this case, light energy, does it produce every second. Okay, right, or actually uses, probably more accurately. Okay, 0.4 kilojoules are added in half a minute. Okay, so again, we're giving the energy and the time, but now you've got different units. Okay, but nothing difficult. Okay. Power is energy over time. What's the energy? Well, I might be tempted to write 0.4, but then I might say, all right, hang on, that's a kilojoule. Yeah, I have to work with joules. Kilo mean 1,000. So if I want to know how many joules, it's going to be 0.4 times 1,000, which is 400 joules. Divided by half a minute. Again, I shouldn't really write here 0.5 because that's in minute. I must write down in seconds. How many seconds is half a minute? 30 seconds. So I need to put that into my calculator, okay, and I get 13.33. We usually use 2 decimal places, okay, 13.33 watts. Okay, what is the unit of power? What is the unit of power? Absolutely. Okay, a motor with 100 watts, okay, so a motor has 100 watts power, works for 1 minute. Now we want to calculate the energy. So again, like in the last lesson, the lesson before that, substitute and then rearrange. So we're going through here. Do I know what P is? Yes, P is 100 watts. Okay, I'm going to write 100. E, do I know how much energy? No, that's what I want to calculate. So I'm going to write down energy. T, do I know how much time? Yes, 1 minute. Should I write 1 minute? No, of course, I have to write down the answer in seconds. If I'm working with watts, that's joules per second, I have to work with 60 seconds, okay? So 60. And then, simple rearranging, okay? You substitute first, and then you rearrange, so you'll get that substitution mark. 16 times 100, energy is equal to 60, and then 2 zeros. 6,000 joules. The answer is 6,000 joules. Okay? Let's do one more question where you have to calculate the time. Pause that. Okay. So last question, here I'm giving you the power and the energy. So let's say it could be a light. Let's work with a light. So a light bulb has a power rating, we call it a power rating normally, if you want to see what power they use, how much energy per second is the power rating. Let's say it's 0.01 kilowatts. Okay? And let's say it used, it used 100 joules of energy. The question would then be, how much time was it left on? Okay? So we're going to go here, right, P. Do we have P? Yes, it's 0.01 kilowatt. But I have to write the answer in watts, isn't it? So 1 kilowatt is 1,000 watts, just like 1 kilogram is 1,000 kilogram, 1,000 gram. Okay, so I need to times 0.01 by 1,000, in other words, 10 watts. So 0.01 kilowatt is 10 watts. Okay? That is equal to the energy, which I know is 100 joule, divided by the time, which I don't know. Okay? Now I've got to rearrange this. How would I rearrange it? I time it by T to move it over here. So I'll write 10T equal 1,000 or 100. And then divide by 10 to get rid of that 10. I'll get 10 seconds. Okay? So the answer was that this bulb was left on for 10 seconds. Okay? So that should cover all the type of question that you're going to have with power. Okay? I'll get you to practice that. In the next few lessons, we're going to take our time and look at questions where you have to use more than one formula, so more difficult ones. Okay? See you then.